My name is Suraya binti Masroom. Today I'm going to show you lab activities on how to investigate a malware exploit. We are going to use several tools or monitoring tools such as Kibana, Segul, and Wireshark. Alright, let's say you decided to have interview for a job in a medium-sized company as a tier 1 cybersecurity analyst. So for that interview, you have been asked to demonstrate your ability to pinpoint the details of an attack in which a computer was compromised. So you are going to use Segul, Kibana, and Wireshark in the security onion VirtualBox. Let's say the event details happened in January of 2017, right? So you need internet access as well as the Oracle the onion virtual machine. Okay, let's start with Kibana. Open your Kibana, log in your Kibana analyst, your Kibana account, password, CyberOps. Okay, this is the first dashboard. Look at the click at the Kibana. We have discover, visualize. So click at the dashboard. This is Kibana. So you have to set the range of event. Let's say because we are going choose absolute date 2000, we are going to observe from 1 of January 2017 until 1 month event until end of January 31st January. Okay, go. Okay, let the face of Kibana make it bigger size. Okay, go to the needs, look at the event of needs. We are going to see at the event needs. Actually you have to narrow down. This is the alert over the time, so we have to narrow down by dragging to the right. You have to do it several times until you get the first event. Okay, maybe. Alright, this is the first event where you can see 23 count event. This is the first event, happened at time 22 at 54 minutes 42. Now look, go down to the needs alert. Okay, and expand the first event so you can see the detail of the first event. Okay, so what is the time? 22 at 22:54 minutes 45 seconds. Okay, can we find the source IP? The source IP is 93. And the destination IP is 129. The destination port is, can we find this 80, which is HTTP. And the classification of the alert, we should find the classification of the alert. Find the classification of the alert should be a Trojan activity. Alright, and then the destination geography name is, I think we can find here, Russia. So and then this is the signature info. So we have to click this. Okay, and go to the link. So this will take you to the emerging threats not alert rule for the exploit. So we have to click here and we can see the content of the exploit. So we can examine details of the rule. Okay. So what is the family of this event? Is the post exploit key RIGISS, I guess. RIG exploit. So what do you think the severity of the exploit is? Suppose a major severity. Major here. Signature severity is major. So what is the exploit kit? Okay, you have to find the answer on the internet. Exploit kit frequently use what is called drive-by attack. Okay, exploit kit is an exploit that use multiple website and redirect to infect a computer with malware. So, right? Look back to the Kibana dashboard for the needs, and we have to find out detail on the ID. Here is the ID. Click on the ID. Cat me window will be displayed on another tab. So you have to examine the first block of the blue tag. This is the request from the source to the destination web server. You have to note there should be this is the website. Okay, there should be request from the source to the destination web server. The two URLs are listed in the block. First is tag as SRC referral. This is the website that source computer first access. However, this server referred browse HTTP GET request to the SRC host. Okay, something in the HTML sent to the source to the site. What website did the user intend to connect? Here, the website referred to homeimprovement.com. The website that intend to connect, that the user intend to connect, is homeimprovement.com, referred by SRC source referral. So what did the browser refer the user to? The browser refer to the refer to thaibanme.com. Can you see what kind of content is requested by the source host from banme.com? The content zip file. This is the content of the zip file and the flag. This could be a malware file that has been requested for download. It is probably a malware file because it is compressed. Alright. Okay, then we go back to the Kibana. Choose the event. Kibana. We try to define event for at the HTTP. Okay. HTTP. Set the range to 27.1. Alright, we have to set the event range to 27 of January 2017 until start from 27 until 27 of 1. Okay, to 27. Okay, 27. Okay, 27 to 27. Alright, go. Okay, we have 166 event. Scroll down the HTTP site section of the dashboard. And we have to find the URLs by searching. We should find the URL. Here, this is a HTTP site. So what are the sites is likely part of the exploit campaign? We can see Bing, you can see P27 home improvement, TubeBandMe, Google Retort. Okay, these are the website listed, and then we have to find which of this site is likely part of the exploit campaign. Okay, part of the exploit campaign is Bing, P27, home improvement, Time, Google Analytics. Okay. What are the type MME type listed? You can find what are the type limited. Here. Count type can be image. It consists of text, plain text, images, application, JavaScript, shockwave, flash, shockwave, JSON, icon, X-icon image. Okay, that's about the Kibana. Next, we are going to explore Sequel to investigate the exploit in more details. Okay, now in part 2, we are going to investigate the exploit with Sequel tool. Let's start. Let's open the Sequel. Login. Password CyberOps. Okay, you have to select all sensor. Start the Sequel. Okay, this is the window for that listed all the alert event, and this is the window to show the show packet data. Let's maximize first. Okay, you have to select which alert that you want to see the detail. This is the TCP header, TCP IP header. This is the data. For each alert, you can see the show rule here. You can maximize in order for you to study the content of the rule later for the event. Okay, so let's say we are going to investigate event from 5.2 to within a minute, 5.2 to 5.78. all right, look at the question, the scenario. Sorry, minimize. No, not minimize. Okay, the timestamp for the first and last alert. Okay, we start with 5.2 to 5.78, and we select alert ID 5.2. okay, from here, and then you can see the ID signature rule here. We have to find the family triggered in this alert. Okay, family triggered 5.2. You can see malware. Is there any family? Yeah, here, family, malware family, pseudo dark leech. Okay, maximize. We maximize the Sequel window, and we want to see the event message. You can drag to make the event message longer so that you can see the event message. So can you see the exploit kit EK for alert 5.25? So you can click the alert EK. So you have to find what are the exploit key involved in this attack. So okay, we can see here exploit kit RIG exploit kit reg. Okay, exploit reg ek exploit, same reg ek exploit. And other information we can see from the event message, the Trojan type, name, ransomware and server, at alert ID 5.75, 5.76. What is the best vector? From the best estimate that you can looking at the alert so far. What is the best vector? You can see. Affected product web browser affected. The attack seems to have taken place by visiting a malicious web pages. Now we are going to look detail the transcript of events. We start with 5.2 event. Look at the transcript detail. Here we can see the blue one is the what we call request. The red one is the response. So from here, what are the referrer? Look at the referrer term. Referrer is bing.com. The user search home improvement modeling your kitchen at the Bing website, and then the user click homeimprovement.com. This is the homeimprovement.com. Okay, close. Go to 5.24 alert transcript. This is the EK transcript. 2.24. Even to transcript. Okay, look at what kind of requests involved. Okay, we can see the first request, get, HTTP get. What are the file? Can you see the file? The file is javascript.js. And what you can see what is the referral website. Home improvement. The referral website was home improvement, and the host website is retrotip vision banner. How the content is encoded gzip, zip compressed file gzip. Okay, now close. We can go try to look at Limo 5.25. Okay, open the transcript window. See how many requests and respond. The blue one is the request, the red one is respond. 1, 2, long respond from the two messages. 3. Okay, we have 3 respond and 3 requests. What is the first request? Which is to get Vivaldi. Who is the referrer? Is www.homeimprovement.com. Modeling your kitchen cabinets. The host server request to tubenme.com. The file type is gzip, compressed. So the response encoded is gzip. What was the second request? Look at the record. Is a post to OKCH, this one at Vivaldi, right? The cost server request is tubenme. It's a zip file. The third request, go to the third request is third request. This is second response. Third request is get monkey. Referrer is tubenme. The content type, can we see the content type? Window referrer. Accept monkey. Mozilla application. What are the first character of the response? content type, or the third response, the third response. Okay, the third response, this one. What are the first character? CWS. The file type is shockwave, flash file, shockwave. What the file downloaded? Okay, CWS is a file signature which is used to identify the type of file that represent different type. Go to the website which is Wikipedia. You have to go to website Wikipedia. Click this one. Okay, and then use Ctrl F. Find box SWF. It's going to open the file, search the file signature. File signature. Find the CWS at the list of file signature and detail. You can see it is actually a .flash file. Okay. Close the transcript windows. Okay, right click and click the file 5.24. We are working just now with 5.25. Sorry, 5.25. Okay, then we have to right click the ID again and choose network miner. Go to the file tabs. There are 3 files you can see here, 2 HTML file and 1 SWF file, flash file. Okay. And next we are going to use Wireshark to investigate an attack. Wireshark. At the alert ID 5.2, we are going now we are going to use Wireshark to see the content of the packet. Go to Wireshark. Alright, so you can see a list of packet transferred. Alright, by default, Wireshark setting use relative time per packet. Which is not very helpful for isolating the exact time an event occurred. To fix this, select view, display time format, select second since the beginning of capture. Okay, now your Wireshark time column has the date and timestamp. Here, can we see the question first? We go to Wireshark. Okay. Select the you can see the time format change to second. Select the first packet in the packet detail area. Alright, select the first packet, expand the HTTP application data, expand the HTTP. You can see detail on the HTTP. Number 4. HTTP. Okay. You can click on every column so that you can see the ascending based on application. So for the first event HTTP, okay, click the TCP protocol and you can see the detail. HTTP Hypertext Transfer, see the detail. And what website can you see here? The website, Bing referral website. What website directed the user to do the home improvement? From the bing.com. So now we are going to view the HTTP object. Choose file. We have to view file, export object, HTTP. Export the HTTP object is below. In the list, select the remodeling, this one, and save this file in your home folder, home analyst, remodeling, save, close, open SQL. Click 5.24. And choose Wireshark. View. Time display format, seconds since the beginning of capture. Find HTTP. Okay, what is the HTTP request for? Click detail. HTTP. We have to protocol. Find for HTTP. See the HTTP 0.020. What is the HTTP request? Can we see the yes, this one, yep. Application JavaScript. File name dle.javascript. The host server retrotip visionnurbana.com. So I'm going to save this file. Export object, HTTP, JavaScript, save. In home folder, JavaScript, save. Alright, close. Okay. Close. Next, we are going to choose 5.25 again. Go to Wireshark. Choose HTTP protocol. Change format, view, second beginning of capture. Right click on the host information. Host information, okay. And choose apply as column. Go detail, hypertext transfer protocol. In the packet, expand HTTP, right click on host information. Host information. Host information. Apply as column. Now here you can see host information as additional column. To make room for the host column, right click on the length. So we don't want to see length. Disable length column. So you can see the name of the server here. So you can see here. Okay, our next step is to create a hash for an exported for the exported malware file in Wireshark. Tu Benny file export object HTTP. We have to save the 2 HTML file and one. Okay, we have to save all files to our local home directory. Now that you save the 3 files to your home folder, test to see if one of the files match a null hash value from malware. We have to click go to this website. Wicho.com. And find, okay, we have to find at the terminal first. Minimize. Sorry. Minimize Wireshark. We go to terminal, application, utilities, terminal. Okay. Application, utilities. Sorry. Application, utilities, terminal. Okay, list minus L and grep minus I Simon key. Yeah, we can find Simon key file. The Simon keyword. Okay, Simon key. So we're going to generate a hash file for the Simon key flash file with the command SHA-1 sum. Alright. Okay. SHA-1 sum. %3 %3. So you have to type the first letter %3FB because this is a long file name. Then you have to press tab button, so it will complete the file name. Enter. Okay, now this is the compressed code for the file. You can see 97A, begin with 97A, ending with 72930. Okay, so you can also generate a hash value by using network miner. Right click and then choose network miner. Okay, and then you have calculate, select 5 tabs, right click the SWF, right click and calculate the see this it is the code is same, begin with 97A, ending with 7290. Okay, the same hash code. Okay, upon the web browser, virus total, and search the tab, enter for, okay, search this one, search this file, virus total, search this file, sorry, virus total, so no, refresh, search, start again, virus total, you have to copy this. I forgot to copy this one. Search, sorry, I want to copy this code. Copy, why it cannot copy here? Virus total. Maybe we can see, we can copy from the terminal. Copy and go to search. Control V. No, it cannot get the file. Minimize. Okay, can we copy from the terminal? Can we copy from here? Right click, copy, and go. Oh, because this is virus total. Oh, I have to find web from here, file. Okay, I maximize this one. Analyst. Minimize. Go to application, internet, virus total.com, and search. Okay, search what we can get from here. The answer may vary, but the response you can verify from the SWF is part of our exploit. Alright, it's part of exploit. We can verify that SWF is part of the RG EK exploit kit 32 and of 55 errors. We have 55 errors. We go then. Now we are going to explore alert ID 5.37. 5.37. Okay, and find the similarity in the alert. Go to pivot to Wiresharks and look at the HTTP. The similarity to the earlier alerts, yes, there is similarity. It should get post and get request to tuber name and records object, export the object HTTP. Yes, same. We have 2 HTML file and 1 flash file. But the file name are different. So I'm going to create a shell file. We are going to create hash file for the SWF. Okay, right click, network miner. Okay, calculate the hash file. The hash file begin with 197A ending with 72990, which is the same malware that has been downloaded in the previous HTTP. Even now we can see that even the two hashes match. Even the two hashes between this and the previous hash matching each other, they are actually having the different file name. Okay, now we look at the last 4 events in the circle. So there seems to be post-infection. 1, 2, 3, 4 post-infection. As we can see, all the 4 alerts concern with communication with the malware server. Query to the malware server, which is the start top domain that we studied before. We found that from the virus total, start top domain is a malware. It's a malware domain, a malware website. What is interesting about the first alert in the last 4? In the last 4 alert is we can see there is sends a UDP code 124. Now we can see the UDP code. Maximize this one. 20 to CP 27. Okay, 27 UDP code to the ransomware check-in server. UDP, okay, can we see? So the type communication is taking place at the second and third alert. Second and the third alert. There are DNS requests to malware domain. The review are initiated from the local host. It is unlikely that there are the result of normal user activity. They must be sent by the malware file. The start domain doesn't look like a valid domain. So we can go to virus total and check star dot, check URL for star, let's say x dot top. Some sort of detection can be seen, can be detected by the virus total. It is a malicious domain, and that still triggers alerts. Then we have to check the last alert. See the file name. Go to Wireshark, import object HTTP. What are the file name? We can see the file name. There is a file. The file name is begin with EE7EA D39 and so on. Okay, next we continue to part 4 to examine the exploit artifacts. Alright, we close first all the windows here. So many windows has been executed. Okay, it's not close. Virus total. Close network manage. Okay, now part 4 is the main exploit artifacts. In the security onion, open file. We open the remodeling kitchen cabinets using text editor. Open with gedit. So we have to find the head and body of the this is the HTML page. The script text in the header is JavaScript. Header, we can see at the header is a JavaScript from RetroTip, and then the iframe that look content tub can be we can see the definition in the HTML body. You have to find, there is the iframe. Sorry. Yeah, the iframe src http tube and me. The file requested http java. Okay. Now we have to open the JS file. We open the JS file, open with gedit. We can see document right, div class, iframe crc http tube.me. It's a JavaScript document right. It's a JavaScript document right. We'll write the content to the web page creating iframe that takes the user to a URI at tu.benme.com. The code in the JavaScript file attempt to avoid detection by splitting the end iframe tag into two pieces. This one. Alright. Okay, in the text editor, open txt.html file. Start Vivaldi. Export the file name. What color file? Okay, open. So this is HTML. This is an HTML web page. It called a start function. It is hidden. The start function actually it writes to the browser window. It creates an HTML and submit the variable normal URL through post. The normal URL variable equals a URI at tu.benme.com. The get browser function is to determine the type of browser that the web page is displayed in. Okay, now we do reflection. Exploit kits are fairly complex exploit that use a variety of methods and resources to carry out an attack. Just now, we learned about Kibana, Sequel, Wireshark, and then we can use different methods to hash the code. This is interestingly, case may be used to deliver diverse malware payload. RG case may be associated with a number of different malware payloads. The following question, okay, may require to investigate the data further using the tools that were included. Alright, the EK use a number of websites. Okay, we are going to complete this table. www.bing.com, IP address not available search engine. www.home improvement, IP address is 104.28.18.74. And then we have URL retrotrip, which IP address 139.59.160.143. The function is to execute malicious JavaScript. And then we have tu.ben. The function is to deliver malicious .flash file, exploit landing page, and so on. Okay, that's all for our lab activities. All the best for you to explore by all the tools that have been taught to you just now. Thank you very much.